Hi, this is Tarik Rashid. Today class is artificial intelligence or advanced artificial intelligence, by the way. Random forest is one of the machine learning algorithms that depends on decision tree. Actually, the background of random forest comes from decision tree. So today's class is part one, and part two is a practical part. So part one is a theoretical part of this algorithm, and part two is a practical part. So random forest is an ensemble learning. So it's a collection of learning method that construct a collection of decision trees and combines them or combines their outputs to produce a more accurate and stable result. It can be used for classification. We are going to take the majority of voting, or we do averaging if it is a prediction of regression type. Now, who invented this algorithm, or who coined first time this method? It was by Leo Breiman, year 2001. Okay, he had a famous paper, and that paper titled Random Forest. So, theoretical roots, as we said at the beginning, depends on decision tree, card, and it has also one technique that uses Bootstrap aggregating, which adds random feature selection to bagging. So that's the basic idea. Now, this is the algorithm. If you check the algorithm, start, you have tree 1, tree 2, tree till B, so many trees, and you draw bootstrap samples. You repeat some features in the data set, and you create a tree. And you do the same. You can do bootstrap. You can select a few trees or several trees, and at each tree, you select random subset of features and choose best split, and then later on either do voting among these trees or averaging them. So that's the basic idea of the algorithm. Here we have also, in a single decision tree could have low bias, high variance, and random forest aims to reduce variance without increasing bias too much. So bias could be error due to wrong assumption in the model. A model with high bias is too simple. It cannot capture the true pattern, the true sample. Linear model for nonlinear model creates high bias. And also variance means that sensitivity of the model to training changes. Okay, the changes in the data creates variance, which is good for overfitting, by the way. So two sources of randomness. We have data randomness, bootstrap sampling. Each tree is trained on a different tree set or tree data set. And also we have feature randomness. At each split, only a subset of feature is considered. Now, why this algorithm works well? Well, it works well because if the tree is independent or not related to each other to some extent, then it works well because it can produce good accuracy and then combining them and then reduce overall error. Now, mathematical formula. So we have tree data set 1, tree data set 2, tree data set 3, and so on and so forth, till tree data set B. And then you aggregate them or averaging them or taking the voting among them for classification, or for regression, you take average of all three data sets. So what are the advantages of a random forest, high accuracy because you've got so many trees and kind of overfitting will reduced, performs well in many domains, and also compared to a single tree, handles nonlinear data, and it captures complex relationship, good for noise, error cancels across trees, and also provides ranking of features and works with large data set. Disadvantages, less understandable, not easy. I mean, if you have a decision tree, more understandable. Random forest, because you have several trees, it is hard to kind of understand. Or understanding is difficult relatively to a decision tree. Computational cost, again, large because you are not dealing with one tree, you are dealing with several trees. Therefore, you might have too much complexity in terms of calculations. Again, because you've got so many data sets or so many tree data sets, you'll have memory usage. You'll have more memory for all these features, variables, samples, because the samples are repeated with different values. So you'll have memory usage. Slower prediction, it's not a single tree, it's several trees. Diminishing returns after many trees, improvement slows. Like if you've got so many trees, then improvement slows. So here we have just a little comparison between decision tree and random forest. Inaccuracy is moderate decision tree, while random forest, it gives you higher accuracy than decision tree. In overfitting, decision tree is too high, this one too low, because then you've got so many training tree data sets. So it means that you'll have a better way to tackle the noise. I mean, you've got the noise, better way to tackle overfitting with this noise that you have. This is easily can interpret decision tree because this one has several trees. It is a low scale of interpretation. Decision tree is not very stable in terms of stability. It's low, and this one is higher. So that's more or less about today's class. This random forecast, which comes from decision tree. Stay tuned for the next practical, which is practical part of random forest. But also you can watch other videos on decision tree part 1 and part 2. Then you'll see the true implementation of how these random forest trees are implemented. Thank you very much and stay tuned.